Okay, so this is a video for Math 2, and I'm going to start by going over the rest of these problems that we had done in class. And those are, it's on the blue sheet, you may remember. Okay, so I'm not sure exactly where we left off. So I'm just going to go ahead and do the whole thing real quick, but focus on the last few problems. Okay, so we were trying to decide if it was side, 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 angle, side, angle, angle, side, or none of the above. So the first one, we have a reflexive side here, and so we have a pair of sides, pair of sides, a pair of sides. This is side, side, side. Okay, we've got a pair of vertical angles here, and so the side that we have here is connecting the angles, and so that definitely is going to make this into angle, side, angle, because the side is in between the two angles. All right, we got vertical angles here. This is side, angle, side. We have a side in the middle here that is reflexive, and so we have angle, side, angle. Another reflexive side here, so we have side, angle, side. Vertical angles again. We have right angles here, which are going to be congruent. The side, you'll notice, is not connecting between the angles, the right angle and the congruent angle, so this is angle, angle, side. The S is on the end because it's non-included. All right, we have reflexive side, side, angle, side. This one has a bunch of angles. We have angle, 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 and angle, angle, angle is not one of those. So this one is none or not possible. This one is very similar to this one up here. This is angle, side, angle. We have a reflexive side here. This is side, side, side. We have vertical angles. The side does not connect between the angles, so this is angle, angle, side. Here we've got side, side, side. Okay, then we have a pair of angles and a pair of sides, and it kind of spells a bad word, doesn't it? So that one doesn't count. That one actually is one of those that doesn't work. Let's erase that. Okay, so it has to be a side that's included. If I knew that this pair of angles here were congruent, then it would be side, angle, side. But since it's not, this is none. Okay, this one we have a reflexive side, but the angles are not matching. They're not corresponding. So this is none. Okay, this one we've got parallel lines. So with parallel lines, if you extend those parallel lines and you look at this transversal in the middle, you get alternate interior angles right here and here. Okay, now these triangles, those told us it was parallel, but they do not tell us they're congruent. So that is not a pair of sides. The pair of sides we get is the middle, the reflexive one. So this one is angle, angle, side. This one right here, we've got vertical angles. We got a pair of sides, a pair of angles. The sides do not connect the angles, so it's non-included, so angle, angle, side. This one got cut off a little bit, but we had a right angle here, and this is side, angle, side. Here we've got a reflexive side, so this is angle, angle, side. This one just does not give you enough information. We have a pair of sides, a pair of angles, but that's it. There's nothing else we can infer from this. So this is none or not enough info. Okay, and one more. We've got a pair of parallel sides again. We use this as a transversal. We get alternate interior angles here. And then we have side, side, and then we have the angle in between, so side, angle, side. Okay, so that's just that. We're going to cut these up and add them to our notebook next week. But for now, what we're going to do is we're going to start the next section. And so this is going to be in your notebook. There's no printout for this one. Okay. We're looking at section 3, 4. You can just directly put this into your notebook, and this is going to go onto page 35. So you can just open up your notebook and just write this down. I'm not going to have a printout or foldable or anything for this. And the title of 3.4 is using, I think it's using corresponding parts of congruent triangles. Okay, so looking at or thinking about what we've learned, we learned first that congruent triangles means that all the sides are congruent, all the pairs of sides, and all the pairs of angles are congruent as long as they're corresponding. And so we first looked at how do you do a proof for that. And then we looked at these shortcuts. So we can we're going to practice these proofs next week. If I have some time, I'll throw in an example here. Actually, I'm going to have to do an example to do the ones for today, so you'll see an example. But pretty much instead of finding all of the sides congruent and all the angles congruent, you just find what you need. You just find side, side, side. You just find all the pairs of the sides. Or you just find angle, side, angle. They're just like mini recipes. They're smaller recipes. Instead of finding all the sides and all the angles like we talked about, you just have to find 3 sides for side, 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 or 2 angles and a side, or a side and an angle and a side. Okay, so once we know that you have congruent triangles, so let's say we have this. If, and I'm going to draw a little sketch of a triangle here, and another one that's the same, so we have congruent triangles. So let's say if we have that triangle ABC, and we have a triangle DEF. And let's say that we know that this is congruent to that, and that's congruent to that, and we know that this angle is congruent to the angle. So that would be congruent by side, angle, side, right? So if we know this, so we have triangle ABC is congruent to triangle DEF, in this case by side, angle, side, well then we can prove other things. So then we can prove other things are congruent. So the angles and the sides that weren't marked, so then we can say maybe angle B is congruent to angle E, right? That wasn't needed for our proof, but since we know that the triangles are congruent, we can say, well, the rest of their parts are congruent, not just the side, angle, side. Okay? Or you can also say side BC, segment BC, is congruent to EF. Or we can also say that angle C is congruent to angle F. So basically saying all the rest of the stuff is congruent. All right, so the reason that we're going to use to explain that is something called, we're going to write this out here, corresponding parts of congruent triangles are congruent. Now that's kind of a long statement. So often what you'll see is an abbreviation. You'll see C, P, C, T, C. That's usually how it's written, CPCTC. And it stands for corresponding parts of congruent triangles are congruent. And sometimes you even see CPOCTAC. I've seen some textbooks use that, but they mean the same thing. And to use this, it's really important to know when to use this. You use it when you have already congruent triangles and you need to prove their other parts are congruent. So it is not a way to prove two triangles congruent. Okay? So if you have like side, 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 angle, 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 side. Okay? CPCTC does not belong in this group. Okay? It's not part of that club. It's used differently. So how it's used, when you use it, the first thing you want to do is prove two triangles are congruent. After you have proven that two triangles are congruent, then step 2, use CPCTC to prove other parts, corresponding parts, are congruent in the triangles. And there's an optional third step, is you might need to do another thing using those parts. So you use the congruent parts from step 2 to prove something else. Whatever you're trying to prove. It depends on what you're trying to prove. Okay, and this step may not even happen at all. Okay, so I'm going to go ahead and do an example. And if you're running out of room when I do this example, feel free to go on to page 34. Okay, so let's do an example. Okay, so I want you to draw this picture. It's kind of messy. You get the idea. So you have like two right triangles sitting next to each other. So A, B, C, D. All right, with every proof, you're going to be given some givens. So given D is the midpoint of AC, and AB is congruent to BC. Prove angle A is congruent to angle C. Okay, so let's think about this first. Remember, the first step is you have to prove that the two triangles are congruent. Now, how you're going to do that is going to be using one of these, right? These are the ways that we know. So let's think first about which one we would use. But let's identify what our givens tell us here. Okay, D is the midpoint of AC. By the definition of a midpoint, that means that AD and DC are going to be congruent. That's going to have to go in our proof somewhere. Okay, next, AB is congruent to BC. They just give us a side. AB is congruent to BC. Okay. All right, so what are we going to use? Well, we have a reflexive side here, so that's going to be side, side, side. So for this particular case, I'm going to do a side, side, side proof. Okay, then I could use CPCTC, corresponding parts of congruent triangles are congruent, to show that angle A is congruent to angle C. That's what I'm trying to prove right here, this thing. Okay, don't think that you have that to use to prove the triangles are congruent. This doesn't exist yet. They're not giving that to us. It's not true. Just pretend it doesn't exist right now, okay? All right, so let's do a two-column proof. Statements, reasons. Ignore this little line right here. Okay, let's put our givens. D is the midpoint of AC, given, and AB is congruent to BC. Given. You can write the givens all in one statement and then just say in the reason given. You can separate them. It's up to you. Okay, so if D is the midpoint of AC, we saw that AD was congruent to DC. All right, we have to write that down. And our reason is definition of a midpoint. That's what a midpoint does. Okay, so let's keep track of our ingredients here, right? We're doing side, side, side. We were given a side. Definition of a midpoint gives us another side, but we still need a third side. That third side comes from the reflexive side. So we're going to need to list that. So BD is congruent to BD by the reflexive property. Okay, we have our third S. Now we need to just state that the triangles are congruent. Now notice you don't get to just copy this right here that says triangle this is congruent to triangle this. That's what you're trying to prove, right? You have to make that up. And the order of the letters is vital. So if it says triangle ABD, let's do triangle ABD is congruent to, okay, you have to match up the letters, remember? So A goes with C. So if I put A first, then C has to come first. So triangle C, and then B goes with B, and D goes with D. Okay, and the reason that these are true, this is true, is side, 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 not CPCTC. CPCTC would never go with this. It's not how it works. Okay, the next step is where we use CPCTC. Okay, but I want to show you. Basically, step one that we just did, prove the two triangles are congruent, that was all of this. All of this. Okay, it's a big step. But you have to do that whole thing first. So now step two says use CPCTC to prove the triangle other parts are congruent. So we're trying to prove that angle A and angle C are congruent. Now that we have established that we have two congruent triangles, we can say that the other parts on those triangles are congruent. So A is congruent to C, and this is where we would use CPCTC. Although in Math Excel, it'll actually write out the whole thing. It'll just be like a drop-down menu, so you don't have to type anything. Okay? All right, so that's pretty much it for the basic ones. Using the congruent parts to prove something else, we'll talk about that on Monday. We'll do an example of that on Monday. Those are a little harder. Okay? Okay, that's it for the video. I'll see you guys next week.